In this video, we're going to talk about how to plot parametric functions. Parametric functions are just a vector that in each entry has a function of one or two variables. You can have functions declared like we did before as a function handle. First case, we're going to declare three functions of only one parameter. This is going to give us a parametric curve. It's not going to be a surface until we use two parameters. So we have to just declare our functions as we've seen before, add, and then in parentheses the variable, and then we have to use the dot between multiplications and operations between our expressions, so that it means entry by entry multiplication and a matrix multiplication. And then we just call the matrix the function isPlot3 because we're going to plot in 3 dimensions, and the entries are the inputs of this function are just function handles, not as before that it was a matrix. So here we just put our function handles in the right order, x, y, and z, and then we have to give it a range for t to vary from 0 to 100, and here is the number of points that we're going to draw, because this is going to draw a line based on a certain number of points, and it's going to put those points together and form a line. So we're going to draw 10,000 points. We can just go ahead and run it, and it will give us the parametric curve that we wanted. Okay, this function isPlot also returns a function handle, so you can use it to change the parameters of the plot, either the line style or the color or whatever you want to change. So this is for one parameter. When we're going to use two variables, we do the same thing. First thing we do is we declare our 3 functions, but now you see that it's 2 variables, and we just declare the function that we want to surface. This is not going to be a surface, and because of that I'm going to use a different function to plot it, and it could be isPlot3 is going to be ezsurf, because ezsurf, it takes the same inputs, function handles. So we write the function handles at first, and then we have to give it a range. But now since we have 2 variables, the first couple of values, minus pi to pi, is range for the first variable, which is going to be s, and the second is the range for the variable t. So s is going to go from minus pi to pi, and t is going to go from minus pi over 2 to pi over 2. And now because it's a surface, we don't need as many points as for a line, so we're just going to take 20 points. So this, here you have the equation, and this should be an ellipse, but then the axes are not the same length. So if we want to appreciate this as an ellipse, we have to set axis equal. I'm just going to label the axis. When we say axis equal, it says that all 3 axes are scaled the same way. This way we can really see the shape of the ellipse. So there is another example in which I'm going to show you how to plot a parametric surface with a function that is not ezsurf, that is just surf. So because we're using surf, we need to declare our functions the same way as we did before, and surf takes an input. The input for surf are matrices, not function handles as for ezsurf. So we just have to create a meshgrid for our variables, I'm going to plot it from minus pi to pi, both of our variables. That's the thing, because we cannot plot t from minus pi to pi and s from minus pi over 2 to pi over 2, because here when we're going to evaluate our function, these two matrices must have the same dimension, otherwise it's going to give you an error. So now we just create our matrix x, y, and z, which is the evaluation of our function at all these combinations of points t and s from minus pi to pi. So we just, here we created our three matrices, and then we're just going to surf that those three matrices, and it's going to give us our surface. Another way to do this is by using ezsurf as before. So if we want to use ezsurf, we can just, we're gonna just plot the same function. We're gonna plot the same function, and we're gonna use ezsurf. And here we have to define from minus pi to pi for t, and from minus pi to pi for s. And it's going to give us the same surface. And now I'm going to introduce another function that is surf norm. And for surf norm, what it's going to do is going to create normal vectors to our surface. So right now, surf norm is like surf because it needs entries, like it needs the entries to be matrices. So we're going to take this part of the code back. Now we have the matrices that we plotted before with surf, and we're going to just plot the normal vectors to that surface, and the surface using ezsurf. Since we want both of our plots to be on the same graph, on the same axis, we're going to use hold on, so it doesn't just plot this, then erase it, and then plot the normal vectors. And we're going to say, we're going to label the axis, and we're going to write a title on it. Now we're just going to have our surface with the normal vectors to it. Thank you for watching. I will leave the code in the description, and I will see you in the next video.